Hello, my name is Salia Chidraf, and today we are going to be going over how to create a stock tracking dashboard using Dash. To get started, we need to install a few things from our GitHub. And to get to this GitHub, we need to go to Google and type in Georgia Tech Data Visualization Lab GitHub. Hit enter, and we will click on the first link. On this page, you will see all of the code associated with the lab's workshop. To get to the workshop that we're going to go over today, click on repositories at the top. And then click on Introduction to Dashboarding for Python. In this repository, you will find all of the code associated with this workshop. And to download the code, we have to go to this blue button on the top. It says Code. Click on Download Zip, and you should see that the zip has been downloaded to your computer. To open this zip file, click on this little arrow and then click Show in Folder. And this should open the location of the Downloads folder. To actually extract this and work with the files, we need to right-click and hit Extract All. Hit Extract. And this might be different for Mac, but for the purposes of this video, we're going to be using Windows. And you will see that it extracted the folder into another folder. And if you click on this folder, you'll see all of the code inside your own computer. So before we run the code, we need to install a few things first. If you go to the repository page, you will see the installation process is different for Windows and Mac/Linux. So after you run your installation process, let's open the terminal. And for me, I'm running Windows, so it's going to be in the command prompt. And head over to the directory of your code. So for me, it should be in Downloads and Introduction to Dashboarding. And it may be in another folder if you extracted it on Windows. To confirm that you're in the right directory, you can type in dir for Windows or ls for Mac, and you should see all of the code for the workshop. Now you want to hit Jupyter-Lab. And now you should see Jupyter Lab open with the files in the directory. Now that we have our files downloaded and our Jupyter notebook open, we can go over the files in our folder. So if you look on the left, you can see all the files in this folder. And the first file is actually a folder, and it's called Assets. And this is where you will put your CSS or other media files. And this is where Dash would go and find all of those files. If you go back and click on the folder icon, you can see that there are Python files, and these are fully completed. So if you want to run the Dash file without completing the notebook, you can just run this app.py, and I'll show you how to run that file later on in this video. You also have this dashboard.ipynb folder or file, and this contains the actual completed notebook. So if you get lost or if you need help with some of these cells in this notebook, this is where you will find that. And finally, if you close that, you have this hands-on.dashboard.ipy notebook, and this is the file that we are going to be working in today. And essentially, you will need to complete the cells as you follow along in this video. Before we get into the coding part of this workshop, let's go over a few things about this workshop. You might be wondering what a dashboard is, and essentially it is the process of showcasing data in a user-friendly way using data visualization. Dashboarding contains a multitude of views, much like the dashboard on a car. So if you think of that dashboard, you might think of a speedometer, a fuel gauge, or an RPM meter. And like the dashboard, the ultimate goal of all dashboard is to present data to the real world so that users, including you, can track, analyze, and gain insights from your data quickly without having to go through your data or your sensors in the system. And to do this, we're going to be using Dash, and Dash is the dashboard creation Python package, which is created by Plotly. And Plotly is a popular plotting package in Python. The reason why we're going to use Dash is because it offers components and callbacks that display information and aid with user interactions that are implemented in a HTML-like way. So if you think of HTML, each object is a component, and those components can have children in like a nested way. And it also offers customizability, like adjusting the theming and the branding using CSS and media. So if you have a group, research lab, or company, you can use this styling to reflect your branding in your group. And if you work in academia and work with R and Julia, Dash also works with those programming languages. We're going to cover a few things in this workshop. The first of which we have already covered earlier in this video, which is installation. The next thing we're going to do is stock tracking, which is the process of getting stock data from Yahoo Finance using Yahoo Query. Then we're going to go into data visualization, which is where we're going to create financial plots from the stock data using Plotly Express and graph objects. Then we're going to get into the actual meat and potatoes of this workshop, and this is where we're going to implement the data visualization components in Dash. Then we're going to implement user interactions, and this is where we're going to control the views using Dash callbacks. And then finally, we're going to control the styling using CSS and Bootstrap to change how our dashboard looks. Before we get to the actual coding, let's go over our development environment. Today, we are going to be using Jupyter Lab, which allows us to manipulate Jupyter notebooks. And Jupyter notebooks are these files on the left, and they are the files with the extension IPyNB. And these Jupyter notebook contain cells or containers that can contain text like this one in markdown form. So if you double click the text cell, you can see that it has like these markdown syntax. And there are also cell codes or code cells which contain basically mini Python files. So if you run these files once, you don't need to run them again to get the variables later down in the Jupyter notebook. So let's get to the actual coding. The first tool that we're going to use is Yahoo Query. And essentially, it is an unofficial stock tracking wrapper that uses Yahoo Finance data. And it contains historical and near real-time financial data. This API allows us to query the Yahoo Query API. And the neat thing about it is that it requires no API keys, so it is free for us to use. And the reason why we're not using the real official Yahoo Finance API is because it is very janky, it breaks often, and it doesn't work for our workshop. So we're going to import Yahoo Query in this code cell, and this line is where we're going to import it, and it says from Yahoo Query import ticker. And basically what it's saying is from this Yahoo Query API, we're going to import we're going to import the ticker module. And the ticker module allows us to interact with the Yahoo Query API by selecting the company's ticker, and we'll get to that later. And we're going to import pandas as PD, and pandas allows us to manipulate data frames, which are basically CSV files. So let's run this cell by clicking the play button at the top, or alternatively, you can use the keyboard shortcut Shift-Enter after you selected the cell. So the first module we're going to work with is the ticker module, and essentially tickers are symbols that represent a company, and this is going to be the same for any financial institution that trades for stocks. So if you look at Google Yahoo Finance or Apple Finance, they will use the same symbol. So it's like the same across all systems. For this workshop, we're going to be tracking the Apple stock, and Apple symbol is the $AAPL. And we will be using these to query data from the Yahoo Finance or Yahoo Query API. So let's create a cell by clicking the plus button at the top. And let's set the Apple symbol to Apple's symbol. So let's create a variable, AAPL symbol equals the string AAPL. And note that we're not going to include the $, because it'll be redundant after so many tickers. So let's run that cell again. And remember, it's Shift Enter or the play button at the top. And let's create another cell and create the actual ticker using Yahoo Query. So let's create a variable called AAPL ticker and set that equal to capital ticker, parentheses. You should really close it so you don't have any misplaced parentheses. And inside the parentheses, put in Apple symbol. And let's run this and see what this gives us. And it shouldn't give you anything because it's just a variable. But if you want to see the printed version of it, in Jupyter Notebook, you can just type AAPL ticker at the bottom, and it'll give you this text. And this isn't really human readable, so we're going to have to do some more manipulations, but essentially this creates an object that is stored in our system for later use. To actually get some data, we can access a module, which we'll get to later. And one of the modules is summary profile. So after Apple ticker, let's put a period and add summary underscore profile. And there are no parentheses after this. And that returns this dictionary that contains the Apple symbol as the key and another dictionary containing data as the value. And this summary profile contains like just like the address, the business summary, and other information that could be useful for our dashboard. You can also instantiate tickers with multiple companies at the same time. One of the ways is to use a string. So if we do symbols str and set that equal to a string with each company ticker separated by a space. So for example, if I wanted to do Apple, Meta, and Google, this is how you would do it. Alternatively, you can you can pass in a list. So let's create a list with the same symbols, and let's set that equal to symbols list. And it's going to be the same way you're going to create a list in Python, and each entry is a string. So again, let's do Apple, Meta, and Google. And to show you how they are the same, let's pass in symbol string and symbol list and see what that gives us. So for the string, let's create tickers from str and set that equal to ticker symbols str. And to print it out, remember, you can just put it at the bottom of the cell and run it. So let's see what this gives us. Oh, sorry. Tickers from string. Don't forget the S. And again, it gives you this object that's not human readable. So to make it human readable, remember, we can just do summary profile. And again, this gives us a dictionary where the keys are the symbols. So you have Apple, let's see, Meta, and Google. And tickers from the list should also give you the same thing. So let's also do tickers from list and set that equal to ticker symbols list underscore list. And again, let's do tickers from list dot summary profile to show us the data. And again, it should give you the same thing. So summary profile is what is called a module in Yahoo Query. And basically, Yahoo Query gives you overview data about the company, such as the asset profile, earnings, and sometimes non-historical pricing. One of the modules is price, which is pretty useful for our dashboard to display the current pricing data for the day. So let's let's access the price data for Apple. And since we already instantiated this Apple ticker, we can just type in AAPL underscore ticker dot price. And here you can see it gives another dictionary, and it can show you the current price, the day's high price, today's low, today's volume, and other information about the pricing. Another module is asset profile, and this gives information about the location, the operations, and the officers about this company. So again, to access it, we're going to type in AAPL underscore ticker, and then the module name, which is asset underscore profile. And this will give you the similar data to summary profile, but it also contains information about the company's officers, so like the CEO, the COO. So for example, we have Tim Cook, which is the CEO of Apple. So you can think of modules as more static data that doesn't really change from time to time. For stock tracking dashboards, you're going to want some more real-time financial data so that users can see the current pricing and other information about the pricing. So this module data you would have like as some sort of like header to show some information about the company, but it really shouldn't change from time to time. So to get the pricing history, we're going to access it the same way that we're going to access a module. But since this one has parameters, we need to access it like a function. And the parameters for history are the period of time, which is the length of time, the interval, which is the time between points, and the start and end time. So let's get the history for Apple. And we're going to create a variable called hist1 and set that equal to AAPL underscore ticker dot history. And this will return a pandas data frame, and it'll give you a lot of data. So to view like a short form of this data frame, we can type in hist1.head and hit enter. And you can see that it gives you a data frame with the symbol, the date, and the default parameters for this will be year to date, which is this year is 2023. So all the days from January 1st all the way to today. And we're gonna have the interval of 1 day. So you can see the time between each point is a day. And for the pricing history, you can see the open price, the high price, the low price, the closing price, and the volume. So to actually pass in some data, you can specify the variables, and to show like the actual or to see the actual valid parameters that can go into the function, you will need to look at the documentation for the history. And so let's say we want to do 1 year and a month between each data point. To access that, you can do aapl_ticker dot history, and the first parameter is the period, and we're going to set that to 1 year. And the time between each point is going to be 1 month, so it's going to be 1mo, and each parameter is a string. So let's run that, and you can see 1 year will go back 1 year in time instead of y2d, which means this current year until the current day. And the time between the points is 1 month. One thing to note about this function is you can do real-time data by setting this to 1m, which stands for 1 minute, but you're going to be limited by the amount of queries you could take. So I think if you want minute by minute data, you're limited to that every week or so. But you can do 2 minute intervals, which gives you near real-time data instead. So the data that we receive from Yahoo Query, it's not really human readable. So if I ask you to find the CFO of Apple in this dictionary, you would need to go in and look at it like one by one. So not address, not city. You have to go down and say, oh, company officers, I better look in that. And finally, you'll see CFO and Senior Vice President, and it's Mr. Luca. And similarly, it's going to be a little easier for the data frames. So if I ask you to find the volume of January 1st or January 9th of 2023, you would go to January 9th of 2023 and go over to volume, which is a little easier, but sometimes you need data in a quick glance, maybe like less than a second. Visualization will help us with that. And to create these visualizations, we're going to need to import a few things. One of the first things is Plotly Expressed, and this is used to create the most common figures. So you can think of bar, line, and pie charts and other common figures that you'll see in the real world. And we're going to also import plotly.graphObjects as Go. And this is another plotting library from Plotly, but this allows us to create more sophisticated figures. So if I wanted to stack a bar graph and a line graph on top of each other, this would be the way to go. And we're going to also import plotly.subplots to create our subplots. And this allows us to create figures within figures. So if I want to stack 2 figures together, that is the way to do it. So we're going to create a quick indicator first. And basically, quick indicators allows us to, like the name suggests, quickly look at a value. And to create a quick indicator, we're going to use the example for price. And usually when you see price, you would also see like the comparison between the current price and the open price, which is called the delta. So let's first import our things by running this import cell. And let's also instantiate our symbol to be Apple. And we're already going to create this ticker for Apple at the top. So first we need to get the data from our Yahoo query. And to get the pricing data, remember we're going to need to access the price module. So to actually get the price or the open price, let's set a variable called open price equal to ticker price. And remember this gives a dictionary, so we need to access the right key. And the right key is Apple. And we already set that equal to symbol. So let's put symbol in the square brackets, and inside that dictionary, if you remember, so after we access this apple in the price dictionary, we're also going to find the current price, or the open price, and you can see that it is regular market open. So you can copy that and go down to where we set open price and paste it. And let's see what this gives us. So again, if you want to print out something in JupyterLab, an easy way to do it is by just putting the variable at the bottom of the cell and then running it. So you can see that the open price is 165.19. So the other part of the quick indicator is the delta, or the current price. And to access the current price, we're going to do something similar. We're going to set a variable called open or current price to ticker.price, and we're going to access the price dictionary. And then the current price is called regular market price. And let's see what this gives us again. And you can see now that the current price is 167.72. And let's double check this on the actual finance tracker on like a real website. So you can see that the price is exactly the same. It is also 162.72 currently. Obviously this might change if you're doing this on a later date. So if you want to double check, just type in $AAPL in Google or Yahoo Finance or some other finance tracker. Let's actually create this figure. And to create this figure, we're going to have to instantiate the figure. So let's create a figure called delta fig and set that equal to go.figure. And let's see what this gives us again. And you can see that it is just a blank figure containing no data. And we will need to add some data to it. One way to do it is called a trace. And these traces, you can think of them as like a template for a visualization that you need to fill out with actual data. And the trace that we're going to work with is called an indicator. And this is the delta figure that I was talking about. So to add the indicator, let's type in delta fig and type in add underscore trace and parentheses. And I recommend automatically closing the parentheses to make it easier for you to work with, and also hitting enter before you add the figure or add the data within the parentheses. So in the parentheses, we're going to do go.indicator and parentheses to close it. And actually, let's see what this gives us currently. So at the bottom, let's type in datafig. And you can see it changed the figure to this dash, which means we added the go indicator. And you'll see later on how adding data to it will change how it looks like. So one of the things you can change is the title. And to put this parameter in go indicator, let's type in title and set that equal to a dictionary. And again, let's open and close it. And inside the dictionary, one of the values or one of the keys is text. And the reason why we're using a dictionary is because sometimes even these parameters can have more parameters. So later on, we can see that. So after title, we're going to set this to F and then a string. And this will allow us to format it. And inside the string, let's open or close another bracket. And this will allow us to add in a parameter inside the string, which is a neat Python trick. So inside it, we're going to add symbol.upper. And essentially what this is doing is we're going to change the symbol to uppercase. So this symbol, lowercase apple, is going to become capitalized AAPL. So after this curly braces in the string, type in current price. And now the title will be capital symbol current price. And let's run this to see what this gives us. And yep, you can see that it gives us exactly what we want. Now after the dictionary, let's add another parameter. So don't forget this, this comma. And now we're going to add the delta, which allows us to specify the reference point for this figure. And the delta is going to be another dictionary. And the key is reference. This is the reference value. So for our figure, it's going to be the open price because that is what we're going to compare it to. Open underscore price. And here we're going to add another parameter to the delta. And to we're going to change how the price is displayed as a numerical value. So if you remember when we printed out the current price, it gave us 3 decimal digits, which is not really how you would see currency. Like here, you would see it go to only 2 decimal places. So to change that, we're going to change the value format inside the delta. And we're going to create a string and do .2f. And this is just saying we're going to format this open price to have 2 decimal places. Okay, now let's run this. And it shouldn't change anything because we haven't added the value to compare to yet. And that value is going to be the open or the current price. So now after we run it, we get the current price. And you can also see that it also has only 1 decimal place, which will change later on. So now we're going to set the mode to be number plus delta. Oops, sorry. And this will change the display to include the number, which is the value, and then the delta, which is the change between the open price and the current price, or the reference and value. So let's see what this gives us again. And now you can see that it actually shows the delta. If you want to hand calculate this, you can do current price minus open price, and it will give you the same thing. You can see that the open price increased, or the current price increased by $1.65 opening. And now we're going to change the formatting for the value. And to that, we're going to do a number equals a dictionary, open and close, and we're going to add the $sign to it because we're working with numerical or financial data. So we're going to check dollars. And to do this, we're going to do prefix, which is the text before the values. And we're going to set that equal to a $sign. And we're going to change the value format to, like before, not 3 decimal places, but 2. And that should be everything. Whoops. It's value format. Oh, sorry. After prefix, you want a colon, not a comma. So now you can see that it changed our current price to be 2 decimal places and prefix it with a $sign. Okay, now that we created the quick indicator, what if we wanted to create a figure for a price history, which is usually something you would see on a stock tracking dashboard. One way to do it would be to create 365 quick indicators for each day for the last year, which, it works, but it isn't really user-friendly or intuitive to use. So a better way would be to create a line graph, or even better, a candlestick graph. And essentially what a candlestick graph is, this is the candlestick for Apple for, I believe, the last year. And each data point is a day. And you can see if I hover over this candlestick, which is like this bar here, on the left you can see the open, high, low, close prices, the volume, and the percent change between this day and the previous day. So let's add that to our dashboard to give our users a way to view the price history very quickly and efficiently. So let's first initialize our variables. And the variables that we're going to use is, of course, the symbol, which is Apple, the period, which is 1 year, and the interval, which is 1 day. And let's run this. So we already have some code here because it is pretty tedious to create this plot. And first we're going to initialize the ticker to be the symbol for Apple. And we're also going to get the price history already here. One thing to note is this reset index. And this basically resets the price history to be more workable for our data. And then next, we're going to initialize our subplots. And if you forgot what subplots are, it's like stacking figures in like this configuration so that it is contained in one figure. So in our figure, we're going to have two subplots. So we're going to have 2 rows and 1 column. So these plots are going to be stacked on top of each other on the same row. They're going to share the same x-axis, and we're going to put the titles to be the symbol name in uppercase and the open, high, low, close, or OHLC. And the second plot will have the title volume, and this is just the aspect ratio between those 2 plots. And finally, we have this layout x-axis range slider visible, and we set that equal to false because it's not necessary for our plot. And let's actually create our figure. And this will be similar to how we created the quick indicator earlier. We're going to have this figure already initialized, and we're going to add traces to the figure. So let's add the first trace, which is the candlestick. If you remember earlier, we're going to call on the figure, which in this case is not delta fig, but fig. So fig.add trace, and let's also open and close the parentheses. And we're gonna do go.candlestick and open close. Let's see what this already gives us. And you can see there's going to be 2 plots: Apple, open, high, low, close, and volume. But since we didn't specify any data in the candlestick trace, there's no data yet. So now we need to specify the open, high, low, close at the same time for this to work. So the open will be history, and simple enough, it's going to be, first we need to specify the x-axis. And the x-axis values are going to be the dates that we're going to use. So in this case, it will be every day since the last year. So our x is going to be history date. And let's run this. And it hasn't updated yet because we have to specify the open, high, low, close prices first. So our open is going to be simple enough, history open, and our high is going to be history high GH. Our low is going to be history low. And finally, our close is going to be history close. Let's see what this gives us already. And now you can see that it gives us the candlestick. If you hover over each candlestick, you can see the date, the open, high, low, close, and this triangle, which symbolizes the delta. And we're also going to turn off the legend because it is not necessary, because we're only seeing one sample, which is Apple. So to do that, we're going to do show legend equals false. And let's also specify which column it should be in, because if we add another trace, it'll throw an error. So after the candlestick parenthesis, so not inside this candlestick trace, but after that, and we're gonna set the row to be 1 and the column to be 1 because we want it to be on top. And if we run this, don't forget your commas. And it shouldn't change anything. But now let's go on and add our volume. And this should be a lot simpler because we're just adding a bar chart at the bottom, like here in Yahoo Finance. So to add the bar trace, we're gonna do something that we're familiar with. Open, close your parentheses, and then go the bar. And so we're gonna add our data to the template. So x equals history. And note that these should match up because we're using the same data. And our y is gonna be history volume. And again, we're gonna turn off our legend. So let's see what this gives us. And now, because we didn't specify the row and column, it's on top, but we need it to be on the bottom. So after go.bar and the parentheses, we're going to change the row to be 2 and the column to be 1. And you need to specify both at the same time, both row and column. So let's do that. And now you can see the date at the bottom. And if you hover over the data for the bar graph, you can see the actual volume. So for May 12th, you can see that the volume is 182.60 million. Nice. So that is how to create the candlestick chart. And now we're gonna have to do something that is a little funky for our development. Usually you would do this in VS Code, but for the purposes of this workshop, we're gonna work in JupyterLab, which makes making dash files a little harder, but not too much harder. So we're gonna need to bring these code into a function so that we can rerun this code for a different ticker if we wanted to, because that is generally what a dashboard does. You want to go for different datas and then change the view very quickly. So let's do a copy and paste operation. So for this, we're gonna go to quick indicator and do Control C, or you can just highlight this and copy. And we're gonna go to price indicator and hit paste or Control V on your keyboard. And you're gonna want to tab in so that the index should be matching the top. Excuse me. So basically what this is doing is it's going to write this, the code under this two ampersand signs into a file called process_data.py. So if you run this file, it should say overriding process_data.py. And if we go here, it should be the same code. So if you wanted to call on this function, you can do price indicator. Sorry, it's price indicator, and it's a function. Oh, sorry. You need to import it first. So from process data, import price indicator. And now you should see that it gives us the same thing. But if I wanted to change something to, or change the symbol to a different ticker, for example, meta, you can see that we can easily change our data without having to copy and paste this code, but change the variable to be meta. So let's do something similar for this visualization of the price history. We're going to copy and paste. First, we're going to copy the code, and then we're going to go under candlestick chart and tab in, or paste our code and tab in the mismatch index lines. So let's also try this out. Make sure to run your file. So now it should say, let's close this. Now it should have the code for the price history. So from process data, import Yahoo, candlestick chart. And we're gonna do candlestick chart, and we're gonna use the default parameters. And that should give us the same thing as we got up here. So if we wanted to change, for example, the symbol, for example, meta, we can do that pretty quickly. Just change the symbol parameter for the candlestick chart function, and it'll change everything else. We can also change the interval and the period. So if I want to do a period of Y2D or YTD, simply do YTD as the interval, or the period. And then if I wanted to do 1 month as the interval, I just put in 1 MO, and this will do the same for a month. Now that we have the visualizations in order, it's time for us to put it into our dashboard. And the tool that we're using to create our dashboard today is Dash. And remember, Dash is the Python dashboard creation tool that allows us to create a dashboard and style it pretty easily. Before we work with Dash, it's important to do a few workarounds because we're developing in Jupyter Lab. Usually you would work in like a IDE like VS Code, IntelliJ, but for the purposes of this workshop, again, we're using Jupyter Lab. And the first workaround is to write our cells into a Python file. And the reason why we're doing this is because Dash isn't able to run directly from the Jupyter Lab cells. It is only able to run Python files. So the workaround is to write this %write file, file name.py at the top. And this will save the file to the cell to our file system. So let's run this cell that contains the layout. And it should say overriding app.py. And we're going to open a terminal to run this file. So at the top left, hit File, New, and then Terminal. And then in the terminal, write Python app.py. And this will create a Flask server so that we can view the dashboard and view the changes live. And we'll see how that works later on. So let's click on this IP address, which is where the dashboard is located. And now you will see this empty dashboard. One neat trick on Windows is to drag it over and to the right, and then click on the browser window that contains the code. And now you have it side by side, so now you can see your changes live. So let's head over back to handsover_dash.ipynb, and then let's scroll to the dash file system. So the dash file system is very specific on what it requires. The first of which is app.py, which is the file that contains your dash layout code. It can be named anything, but you have to make sure it's the name that is run in the terminal. You can also have other Python files which contain your data, your callbacks, other logic, and I recommend having it on a different file because it just cleans up your code a little bit more. You also have the requirements.txt, which contains the list of Python packages that are required for your dashboard. And this is ideal for developing with other people so that other people have the same package version that you have. And then finally, you have this assets folder, which is very specific because this is where Dash finds your media files, such as your CSS, which contains the styling for your dashboard, your JS files, which is used to manipulate the logic and layout of your Dash application. It's recommended that you do most of the logic in Python because JS can be a little finicky. You also have your favicon.ico, which is the icon that is displayed on the top of your browser tab. So for our Jupyter notebook, it is this Jupyter symbol at the top. And you can also have other media files such as your images, your videos, maybe even music, stuff like that. So now let's actually get into our actual layout. We already have a few things here. And all of the layout is in this cell, which is written to our app.py file. And first we have a few imports. From Dash, we are importing Dash, HTML, DCC, input and output. Dash is the actual import that contains the Dash application, and this is what is needed to make this file a Dash file. We are also having HTML, which is the Dash equivalent of HTML. So if you remember earlier, I mentioned that the equivalent for HTML, a div in HTML is dash.html.div. We also have DCC, which stands for Dash Common Components. And these are used for common user interaction components such as the input or the button. We also have input and output, which is used for callbacks, and these further aid us with user interactions. We're also importing process data, which is our own file, and this is used to load the plots that we created earlier in this workshop. And to actually initialize the app, we have this. We have a variable, and this is set to Dash, and this builds the app so that we can use all of the Dash features. And then we're going to create the layout. And the way to do this is you set this equal to some sort of component. We recommend using HTML div so that it contains everything inside a little div. And each component can have a children, and to set the children, you have a parameter called children, and you set that equal to either a single element like a string if you want to put just text there, or you could put a list if you want multiple children's, and this is what is already here. So then inside this children's list, we have the header. And this header contains both of our title and the button and input field. And if you want to see the equivalent, go to your dashboard, right click it, hit inspect, and you should see the equivalent here. So if you want to see this H1 markdown field containing stock dashboard, you can see the equivalent on the left. So now we're going to run this this dashboard with our visualizations. And to do that, it's worth noting that every time you load a Dash application onto your browser, everything that you need to be there needs to be preloaded. So our plots need to be preloaded. And the way we're going to do this is under your code here, number 1 in the layout code, we're going to instantiate our plots. So first, let's instantiate the price metric or the quick indicator. So let's set a variable called price underscore metric equal to our import from process data, which is process underscore data dot price indicator and Apple. And remember, the default parameter is Apple, so you can omit this and you will get the same thing. We also have the price chart or the price history chart, and we're going to create a variable called price underscore chart. Set that equal to process data dot candlestick chart open close parentheses. And now that our plots are instantiated, we can put them into our layout. So the way you add things to this layout is pretty simple. For example, if I wanted to add the like a summary of what this dashboard does, you can just hit enter after your code here, number 2. And let's say I wanted to add a string and that says this dashboard displays metrics about your favorite stock tickers. And now after I hit shift enter, this should be reflected on the Dash application. Yep, it might take a while, but yep, it's there. So now let's add our plots to this dashboard. And we're going to put this inside a div. So the way we're going to do this is after our string, we're going to add a comma. And then we're going to type html.div parentheses and then close it again so that you don't have any errors later on. And inside this, we're going to add a list. And inside this list, remember, we can instantiate the children's as a list. We're going to add the price metric first. And the way to put this inside the dashboard is that it needs to be in what's called a dcc.graph. And it's basically the wrapper for all of Plotly's plots in Dash. So to do it, we're going to do dcc.graph. Open and close your parentheses. And then, like HTML, you can set an ID so that we can reference it later on. So we're going to set the ID to equal price underscore or dash metric, and comma, and then we're going to add the actual figure. So figure equals price underscore metric. And now it should have our quick indicator. Yep. And you can see that it automatically loads. Earlier it was kind of laggy, but now it did it without me having to reload. So now let's add our price indicator or our price history. So after this div, let's add a comma. And similarly, we're going to do dcc graph parentheses, close parentheses, set the ID to equal price chart dash chart in quotes, and the figure to be fresh chart. Yes. And now our figure is on a dashboard. And this is basically the development process of the Dash system. You can stop here if you want to have like this basic Dash, but for me, I feel like it's kind of not too sophisticated. I want some other things added on to make it more like a dashboard. And one of the things is maybe we can add a news table. And luckily we have the code for that. So if you scroll down to the next cell, you'll see this pre-written cell that contains the code to create a news table. And essentially you can go through and see what it actually does, but at a high level, this creates a header, or first it gets the data from Yahoo Query using this search feature. And we're gonna get the header for this table. We're gonna get the thumbnails for each article entry, the hyperlink, and then the time from the epoch from the news. And the way we're going through all of the news article is a neat thing. Dash allows you to create components iteratively. So if you have like a children or a list of children that have children of the same kind of like structure, for example, rows in a table, you can iterate through it and then manipulate the loop as you will. So let's add this news table to our code. And the first way to do that, or the first thing that you need to do, is you need to uncomment this. So let's remove this hashtag symbol. And you should see that news table is now green. And I want this news table to be right next to the price indicator. So to add a new children to this div, we're gonna add a new span, HTML span. And in this, we're gonna have the children news table and the ID to be equal news dash table. Oh, and we forgot to instantiate our news table because we need to preload it. So the way to do that, we need to call the variable or call the function from our file, which is called news table. And news table equals news underscore table dot generate news underscore table apple. Looks right. So we pre-instantiated the news table table, and then we add the span to our dashboard. So let's run the cell again. See what this gives us. And now you can see that a news table is here. It should look better if we create this like that. You should see the thumbnail, the hyperlink, and the date. So that's that. Okay. But you may have noticed that typing anything into this input field doesn't actually do anything. And that's because we need to add the callbacks to our system. And the way to add callbacks is you need to have the input output in your app.py file, and then write the callbacks in another file. And as a reminder, callbacks are a way to dynamically change the component of a dashboard based on user interaction. So our input field is a way to dynamically change the dashboard. So let's add that to our dashboard. So the way to do that is you have this this decorator, this function decorator called dash.callback, and this is added to any function you want to run whenever this callback is fired. So the callback needs two different inputs or two different parameters. One is the output, which is what is going to change after a change has been found, and the input, which is what is it basically specifies what to look for a change. And the things that we want to change are the price history, the price metric, and the news table, because we want to change the data, those components based on the ticker. And you need to specify the output in the order of the callbacks, or the order of the outputs in the callbacks. So in our return function, let me scroll down a bit in my notes. We first want to call the process data function, or the candlestick function, because that is the first component that is called. So component, or process data candlestick, and our symbol pass through. And the next thing is the price metric. So process underscore data, the price indicator symbol, and then finally our news table. Dot generate news table symbol. So let's write this file. And it'll change, or it'll update, but there's no update yet because we need to uncomment this at the top of the layout file and then run that. Oops. Let's see what we did wrong here. There's no component called price history. Let's see if we have, right, so instead of price chart, sorry, should be price history. Let's run that again. Oh, and it's worth, that's a good error because that allows us to see that the component ID connects to the ID in our layout. So now that that's fixed, this should actually change our thing. Oh, sorry. Candlestick should be candlestick chart. Let's run that again. Now this should work. Yep. And now it updates our function or our dashboard accordingly to the input that we put in the input field. And you may have noticed that any change in the input changes the thing. Basically the submit button doesn't work. And the way to do that is you need this state function. And basically the state function or state parameter in the callbacks allow us to change the dashboard when the state of this component changes. So our state is the input field, and then the input to the state is the number of clicks. And anytime this number of clicks changes, this callback is fired. So anytime the submit button is clicked, n clicks increases by value, and then this will fire the callback. So let's copy and paste our return function or return line from the top, and let's overwrite our callback function. So let's fire that, and that should change our dashboard a little bit. So let's write meta again, and now you see that it doesn't do anything until I hit the submit button. And that's basically the premises of the callbacks. Okay, so you might notice that our dashboard kind of looks a little old, like it's from the 2000s, and honestly kind of unprofessional, like it was made in just like base HTML. And we want professional dashboards to go around in Georgia Tech. So the way to do this is to adjust the CSS of the dashboard. And we have this framework called Bootstrap that allows us to change the styling by adding classes to components. And we're going to have to add a few classes. You might notice previously in the code there's this line that says add class here, and this is where we're going to add the Bootstrap classes to change how it looks. So the first class we're going to add is in add class here 1, and we're going to add form dash control and run it. And now this changes the input to take the whole field, but still it kind of looks a little weird. I want it to be on the top left of the field or of the page. So to do this, we're going to change add class here 3 to navbar. Hit enter. And this changes the CSS for this header, and it changes it to a nav bar. So like a navigation bar at the top allows us to navigate to places. And this is the styling that is applied to the navigation bar. And then finally, we have this submit button that looks a little old. Let's change it to be a little more modern. So at add class here 2, we're going to change the button to be first button. Let's run it and see what it gives us. And now you can see that it's clear, but we want it to be actually human readable to show that it's an actual button. So let's do button dash outline. No, probably. And now you can see that the submit button is still there. But now after you hover over it, it's blue and it gives you a nice blue outline. And like before, it should still work. And now it looks a little more modern. So that's the workshop. If you have any questions, I have my contact details at the bottom. I would happily answer any questions. Yeah, and good luck.